you see things about this, it might be called state reduction or wave reduction or state collapse or quantum wave reduction. All these things are literally speaking about exactly the same thing. That is just the concept of collapsing a wave of possibilities into one definite outcome. The only way to really understand that is to try to wrap our minds around what a quantum wave is. It's one of those very fuzzy topics because there's nothing clear about any of it. There's a difference between a quantum wave and a quantum wave function. Mostly here I'm talking about the quantum wave function, and that is a mathematical system that can determine the probabilities of a single particle. So you can think of it like the surface of the water being the quantum field, and a particle can create a wave in that field if you were to drop something on the surface of that water. The wave function would represent the probability of one of those particles being located in the system. Every single thing around us at a subatomic level can be represented as a particle or as a wave. The wave isn't its own thing. Just like a wave of water is not its own thing. A wave is water, but it is the state of that water, can be in a wave. Just like all subatomic particles can be in a wave state. So they exist as particles, they also exist as waves. The wave is the state of the particles. Just to be clear about that, it's not a one-for-one exact comparison, but it's a good analogy. One way that we know that particles always act as waves, I mentioned before countless times so far throughout these sessions, the double-slit experiment. The idea of that is that they fire photons at a screen that has small slits in it. They usually use a laser for it, and the screen that they're firing those photons at has small slits in it. Those slits are generally about the size of the wavelength of the laser that they're firing at that slit. And then they have a screen behind those slits to see where the laser leaves its mark behind those slits. You could imagine it like tiny bullets, because when you're firing a laser, you're firing those photons, and those are individual particles. You would expect that if they only acted like particles on the screen behind the slits, they would match those slits. Just like if you're firing bullets or anything, it would only go through where those slits are, and you would see roughly two of the same shapes behind those slits from the laser. But what they noticed when they ran these experiments multiple times over and over, they noticed that behind those slits, the pattern of the photons was spread out. When they track these waves and they measure where the waves would have hit on those slits, because if it was acting as a wavelength strictly, it would spread out. It would hit the edges of those slits, and that would cause it to spread out, unlike a particle that would fire straight through. So the pattern behind these slits showed that the particles were acting as waves, and what they realized is that in different spots behind those slits, there were built up spots of those particles, and then there were certain other fuzzy spots where the particles were almost canceled out, and there was almost nothing in a wide spread out blurry pattern behind these slits. And what that shows is constructive interference, which is basically like when two waves hit each other. If the two waves are at their peak, then it's going to cause a much bigger wave. If the two waves are at the dip at the bottom of the wave when they meet, then they're going to cancel each other out. So, and you can see all in between, so if you have one wave and then no wave, or a dip in a wave, then it'll be completely flat. If you have two dips, then it'll be lower. If you have two peaks, then it'll be higher. So they noticed on the pattern behind these slits that these photons were acting like waves. When we're talking about wave collapse, that is a good example of what's happening in that experiment. One way that scientists have understood wave collapse, they have a mathematical formula. There's still missing pieces to it, and it's called the Copenhagen interpretation. I'm sure a lot of you have heard of that. And the Copenhagen interpretation is just a formula that determines the collapse of the wave. Now, there's some speculation here. One thing with the Copenhagen interpretation is that it's commonly understood as a form of objective reduction, because saying that the wave is going to collapse either way, based on a set of predetermined but unknown principles. The Copenhagen interpretation could represent subjective reduction as well, because we only know about that collapse when we measure it. So wave collapse is the probabilities collapsing into one. Another way I've seen it explained is when you flip a coin in our world. I don't really like this analogy, but a lot of them use it. If you flip a coin, in our world, that coin is spinning, and at all times, if you were to stop it and look at it, it would either be heads up or tails up. It's not necessarily true, because it could be edge up at some times, but this is the way people explain it. But in the quantum world, it is both. It is saying that it is both heads and tails at the same time until you measure it, which doesn't make sense in classical physics, and we don't, doesn't seem to make sense to us. The many worlds interpretation would help explain this, but we'll get into that a little bit later on in the video. So the Copenhagen interpretation basically says that if you flip that coin, no matter what, it's going to end up landing on heads or tails. And if you had enough information about it, somehow you would be able to determine whether or not it's heads or tails. That is objective reduction. That's saying that that wave of possibilities is going to collapse no matter what into one of the two outcomes. Subjective reduction says that it never collapses until our consciousness affects it, until some form of measurement and consciousness affects it. Now, how do we determine whether or not something is being reduced? We can't measure it without having some sort of conscious interference with it. So how do we determine whether or not things can reduce without our consciousness? That's one of the great questions here. You said, can I ask, if the result of an experiment is influenced by observation, isn't that due to the interference of consciousness? Wouldn't make sense if consciousness would be a frequency too. It would make sense if consciousness would be a frequency too. You're correct. Now, of course, that is the question here. And we could get into like the Masaru Emoto's experiments with water. What is the frequency of consciousness, or is consciousness a complex set of frequencies that are, determined by a lot of underlying factors? Because consciousness definitely affects these systems in different ways, or at least from what we can tell. But like with the water experiments, consciousness affects the water in different ways. So is there a single frequency of consciousness, or is there a wide array of frequencies for consciousness, just like a wide array of frequencies for the light spectrum? I don't know. That's tough. Like, is pure consciousness white light? And then there might be subtle differences if you can split it and refract it in different ways. That's a good question, Didi. I'm not sure. But subjective reduction is still not widely accepted. You said, what if everything is permitted with consciousness and everything reacts on different levels? Yeah, that a lot of people do believe that. And I do think that's very, very possible. I do believe that consciousness, you can make a strong argument that consciousness is necessary for existence. If everything is permitted with different levels of consciousness, permeated, if everything is permeated with consciousness and everything reacts on different levels, sure. I think you're right. Honestly, if I had to guess, I would say that's probably, based on what we understand, that's the argument that I would make. I could argue against it, but like, if I'm lying to myself and ignoring all the things that we've talked about here, then I could argue against it. But realistically, Yeah, no, I think you have a point. But what is the frequency of consciousness? I don't know. I still don't know that there's one simple frequency of consciousness. That's hard for me to accept. I don't know. I guess it could be just like everything. It could be the collection of frequencies and what, but I don't know. Many worlds interpretation does not necessarily go against wave reduction, subjective or objective, because the many worlds interpretation says that these subatomic particles exist in the probabilistic state at all times, and when you make a measurement or when you make an observation, it says that literally the universe splits into different worlds. Instead of the wave being reduced down to one probability, it actually, we shift our dimension and it splits into its own universe or its own world, and all the other probabilities go on to split into their own worlds. And then if you think about it, there are more wave reductions and many worlds splitting within those worlds, and that ties really well into the super string theory or supersymmetry that we've talked about. So the many worlds interpretation, people say that it goes against wave reduction, but then I'm like, can't the appearance or the illusion of quantum wave reduction be caused by the many worlds splitting? And yes, that's exactly what it would seem like. The thing is, we can't, once the many worlds split, we can't detect them anymore. So there's no way to verifiably prove that as far as we can tell yet. And also the many worlds could go along with objective or subjective reduction. You can be choosing your own universe, and you can choose to split into any possible outcome you want based on this principle, but that doesn't mean, and Didi, like you were talking about how if consciousness is what's permeating all things, maybe, but objective reduction could still potentially happen on all of these scales. And I came across an interesting theory. It's called cosmological natural selection. The idea of this is just like biological natural selection, how different biological systems, living organisms, can gain or lose different functions depending on the practical use that they have in their everyday life for survival. Well, the cosmological natural selection, basically it's the same thing but on a cosmic scale. It says that the universe gains things and loses things based on its best possible probability of creating a universe for life. So that's why we know that there's many other planets out there that could potentially sustain life. We don't know that there's life on them because we haven't been able to detect that, only because of our limited instruments. But the cosmological natural selection says that these universes are formed based on their best ability to create something that will end up sustaining life, which we'll be able to measure and observe it. So based on the many worlds interpretation, you're driving down the road, we're applying this on a macro scale, and there's a universe where you go left, there's also a universe where you went right, there's a universe where you went straight, there's a universe where you turned around and went home. And based on the many worlds interpretation, this is just constantly happening in every moment based on our frequency and our consciousness. So, do these systems collapse without consciousness? This is where the great question comes in. You said evolution is needed to survive. Yeah, it is, because everything either grows or decays, and nothing stays the same. And if it's not growing, then it's decaying in one way or another. So, yeah, that is the natural selection. And that's why I thought that, like, cosmological natural selection is an interesting principle, because it doesn't only apply on a biological scale. Everything that's determined by the universe is shaping it in a form so that we can perceive it. And, I think that's an interesting thought. The other thing that we've talked about a lot is quantum entanglement, and there can tend to be some confusion on these things, because I say dreams are other realities, right? That's saying that every one of our particles exists in a superposition, which is a wave of probabilities at all times. So that would, in theory, would mean that we have completely separate organic biological organisms in separate realities at all times. And the question is, like you were saying, Didi, we were talking about it like last week, I think. Do we keep this stream of consciousness, and is our stream of consciousness our own? And based on the speculation of the many worlds interpretation, if we exist in all possible outcomes, in all universes, in other forms at all times, does that make that us? Or is that simply the mirror particles? Is our consciousness also mirrored in those other realities? I mean, we don't even have evidence that the many worlds interpretation is true. Although dark matter and dark energy, if we could find a way to detect them and measure them, might explain where all those other realities are and how they're woven into this reality. And sure, you could call it speculative, but I do think that if there's any evidence on either side of that, there's more evidence leaning towards our consciousness being woven into those other realities. And the evidence, I would say, for that is our dreams. I would say that dreams that we experience could likely be glimpses of those other worlds from the many worlds interpretation. And am I crazy when I think that? I don't know. You said exactly why I say dreams show us how consciousness works. Yeah, exactly. Okay, so we could talk about collective consciousness, reducing the wave function, and if there is a frequency of consciousness, and I'm saying that I think there's a wide range of frequencies within the frequency of consciousness. What keeps this earth stable? So and this is where we get into Schrodinger's cat. Like, if everybody were to go to sleep at the same time and cease to be waking and conscious of this world, would the world cease to exist at that moment? That is the question. Based on subjective reduction, we would say yes. But if there is an interplay of subjective and objective reduction, Didi, you said, and there is a decay in a dark matter world, talking about light matter, us. Exactly, right? Though? Right. Yes, there would be. And everything in between. So, I mean, it's mind-boggling, but it's like when you get down to the fundamental essence of reality, no matter what you come up with, it's going to be mind-boggling. So these are the things that seem to make the most sense to me. Is there an underlying collective consciousness that is keeping our reality in a reduced state and maintaining that wave reduction for us, so that we're not constantly popping into and out of different worlds, but we're maintaining the stream of this specific probabilistic outcome based on our collective consciousness towards it? I mean, maybe. And then yes, maybe those other dream lives that we live are, we can't just, like right now, I can't just think about one of my wild dreams and in this conscious waking reality start experiencing it instantaneously. I can't reduce the probability of my wave function into that reality instantaneously from where I'm sitting right now, because there's so much built up collective consciousness that is solidifying this outcome of this reality for me right now. But when we're asleep, we may not be influenced by the array of the surrounding frequencies of consciousness around us. Am I being too confusing here? I don't know. So I feel like when we're sleeping, we are more open. We're more open in our stream of our own personal consciousness, and less affected and influenced by the frequencies of consciousness around us. The more that scientists, people much smarter than me, keep studying this, the more clarity we'll find. It seems impossible to detect whether or not there are other worlds that will blink out of our existence and into their own existence. But if there was a way to detect the composition of dark matter, it might give us glimpses into those answers. When we're dreaming, we may be able to more easily tune into the wave function of our consciousness, the probabilities of all of our other particles, particles that are entangled. We're talking about completely separate particles. So if dreams are not the wave function, the probability of our particles, what if those other realities of those dreams, those are other particles that have been entangled with our particles? We talk about entanglement, and we've talked about that before, and I guess I should just mention it here, and that's just when two particles can be affected by each other across massive distances of space, and the effect is instantaneous. So if you take two particles and you entangle them, and the way they can entangle them is if these particles are close together over a long period of decay, they can end up being entangled, or they can also collide them together, and that can entangle these particles. And what we mean when we say that they're entangled is that once you separate those two particles across space, you can measure one particle and that will affect the other particle, no matter what, and it happens instantaneously, faster than the speed of light. And that's also something else that they argue about is it instantaneous? It appears instantaneous, or is it just way faster than the speed of light, which would still, but is there a finite speed to the reaction time? I don't know, but that's not really worth getting into tonight. I mean, it is fascinating, but my point is that do dreams exist as other particles that we have been entangled with, and all of those particles have their own wave of probability outcomes. So when we're tuning into another dream, we might be experiencing our other counter particles that we've been entangled with, and then if something absolutely wild and unhinged happens in those dreams, when we're talking about like really trippy dreamscapes, maybe that's tapping into more of the wave function of that reality of those particles. I don't know. That's taking it pretty far, but because if dark matter was composed of those WIMPs that we're talking about, if those WIMPs exist, then they would produce other particles through decay, and those secondary particles would in theory be entangled with the original particles, those weak interacting massive particles. So that's an interesting point. And entanglement doesn't only happen in the Large Hadron Collider. It doesn't only happen in science labs. Entanglement is happening all around us, and entanglement happens all the time in nature, just from particles colliding or from decaying in different ways. So entanglement is a natural process. So has entanglement been going on since the beginning of our conceptual universe? It's safe to say yes. So as these particles are being entangled, are they being entangled with other particles in dark matter, weak interacting massive particles? I don't know, but I think it's fun to think about. And when I say that dreams are other realities, this is what I mean. Now, how can so many dreams seem so real? Let's assume that the many worlds interpretation is true. That would say that the Copenhagen interpretation still holds up. Subjective and objective reduction are still on the table as major possibilities, and it would also explain what dreams are. Because both of these fields, the study of dreams and the study of consciousness in our quantum reality, these are two things with a lot of unanswered questions. But I think we can bridge the gap between the two, and if either one could be understood more, it would help us understand the other one. That is basically my main point for tonight. And I hope, it's tough to explain these things clearly, and to try to bring clarity on these topics. But I think it's the more we explore it, the more we can understand. Yeah, I think I'm gonna call it a night. I'm gonna go spend the rest of the night with my beautiful girl. Hopefully she's not sleeping yet. Probably not. And maybe she's got the kids settled. If not, I'm gonna go say goodnight to the children. And I hope all of you have an amazing night. I appreciate it. Good night, Dad. Thank you. The music. I got so much music, so everyone can be expecting more of that. I got more old songs and I got a bunch of new songs. So it's been fun. I'll probably throw up a poll to see what we want to talk about next week. But you know what, Dee Dee? Since you've been kind of pulling it out of me so much here, and we might just talk about frequency of consciousness and things of that nature. So yeah, thank you. It's been a lot of fun. I appreciate all your input, all you beautiful souls. Thank you for joining me. Peace and love, everyone. Search D.K space Dream Space Keeper on just about any platform and find me for more information about things like this.